Welcome to qnawire.
This is problem number 53 of the Stewart Calculus 8th edition, section 2.8. Use the definition of a derivative to find f prime of x and f double prime of x. Then graph f prime, and f double prime on a common screen and check to see if your answers are reasonable. So let's start with f prime of x. This is defined as the limit as h approaches 0 of this function evaluated at x plus h, so 3 times the quantity x plus h squared plus 2 times the quantity x plus h plus 1 minus the function by itself, 3x squared plus 2x plus 1. Okay, and this is all divided by h. Our next step is to expand the numerator a little bit. This binomial squared, x plus h, the quantity squared, is going to be x squared plus 2xh plus h squared. Multiplied by 3 will be 3x squared plus 6xh plus 3h squared. Then we're going to multiply and distribute the 2 here, 2x plus 2h, and then we have a plus 1. And then in this part here, we're going to distribute the negative 3x squared, negative 2x, negative 1. And this is all divided by h. So now we identify some terms that might be canceled, such as 3x squared and negative 3x squared, positive 2x and negative 2x, and positive 1 and negative 1. The remaining three terms, 6xh plus 3h squared plus 2h, have 1h in common, so that can cancel with the h in the denominator. Therefore, we're left over with the limit as h approaches 0 of 6x plus 3h plus 2, and as h approaches 0, 3h approaches 0. Answer here is 3x plus 2, 6x plus 2. And that is our answer for f prime of x. Let's do the same for the next derivative. So we're doing f double prime of x, and we're using this function now, the resultant derivative, as the function to evaluate this limit with. The limit as h approaches 0, we're going to do the same steps again, just with the new function. The function is 6x squared plus 2, and we're going to plug in x plus h here, and then we're subtracting 6x plus 2. Put this in some parentheses, all divided by h. Okay, the next step will be to distribute the 6 in the numerator, 6x plus 6h plus 2, and then distribute the negative 6x minus 2 divided by h. Okay, 6x and negative 6 will cancel, plus 2 and negative 2 will cancel, and then we're left with 6h over h, which if we simplify becomes just 6. That's the only remaining term. The limit as h approaches 0 of just the constant number 6 is equal to just 6. So the second derivative we have determined is just 6. Now we have the function f of x is 3x squared plus 2x plus 1. The derivative of f prime of x, which is equal to at 6x plus 2, and the second derivative f prime of double prime of x, which is equal to 6. And we're going to take all three of these functions, graph it on a common screen, as shown here. Here we have the function f of x, 3x squared plus 2x plus 1 in purple. The derivative, 6x plus 2, shown in red. It's a linear function. And then the function for the derivative, second derivative, f prime of x is equal to 6. It's a constant value of 6. And this, these all make sense because starting with the original function f, it is decreasing here up until its minimum value here, which makes sense because the linear function here is in the negative area. its negative values all the way up until this point here where it crosses the x-axis. Afterwards, the function f is increasing. Therefore, the function 6x squared plus 2 must be all positive afterward, and that's true. And then now we look at the relationship between f prime and f double prime. Well, f prime is a linear function, 6x plus 2. It's the slope of all of its tangents line are all equal. The tangent lines here are all constant with constant slope, and that slope is 6. And then that is exactly shown here by the derivative of f prime.